For this video, we are going to check the commutativity and associativity of our star operation defined as a star b is equal to 2 to the power of ab, where it is defined on the set of integers z. So to do that, let's start by letting elements a, b, and c elements of our set z. We are choosing here 3 because for associativity later, we'll be using 3 different elements. So let's start with commutativity. Okay, we need to establish that a star b is the same as b star a for all elements a and b on our set z. Okay, it should work for all. So let's start with a star b. It's already given with direct definition here. A star b is equal to that, so that's 2 times your product of your elements as your exponent. Okay, for b star a, the same thing. This is 2 times the product of the elements as exponent, and since we have here the first element as b and second would be a, it will be structured as b times a. But of course, if we're going to look at this exponent, the coefficients b and a are under multiplication. So the usual multiplication is commutative. So you have 2 to the power of a b here. This would mean we have the same result as for the left hand side and for the right hand side. The left hand side is a star b. It's equal to b star a. For this given item, star is commutative. Okay, commutative, because we have established that no matter which of the same two elements is written first, we have the same result. Now let's proceed to associativity. Associativity. Since we already established or identified 3 elements a, b, and c for set z, we need to show that the grouping a star b star c will have the same result as a star the grouping of b star c. If we could do that, then it's associative. But if we cannot, then that means this is not associative. Let's start with the left hand side. Okay. A star b is already given 2 to the power of a b. Okay, this will now be treated as 1, as this will be still subjected to another star operation but against another element of c. Take note, this would be treated as 1. Okay, that would be our new a here, and that would be the first exponent here. That would mean we'll have here 2, and the first exponent is the 2 to the power of a b, because this is treated as 1 element, and this will be multiplied, that's our a here, to our second, which is c. This would mean this would be our left hand side. The left hand side is 2 to the power of 2 ab times a coefficient c. It's not an exponent c because we simply multiply them as exponents already. Okay, that's the first item, or that's the first result for that's the result of our first side, the left hand side. Let's see if it's the same as having the second grouping. You have a star b star c. We will be starting with this, so that's 2 per definition. It's b and c to the power of b and c, but this is again will be subjected to with a. But if we're going to look at this again, this will be treated as 1, and that's our second element for our second star operation. So our first element is 2, so a, so we still have 2 here in the first, because that's 2ab a times 2 to the power of b and c. Okay, these are already exponents of the exponent. These are just bases of the exponent. This will mean this is just 2 to the power of a, 2 to the power of b, and c. Now, we are targeting here for all possible values of a, b, and c, elements of z. Now, might be some instances where we will have the same result, but of course, for all, we cannot say that. Therefore, we can not say that 2 to the power, let me place it here and change it a bit pen color here. So we cannot say that 2 to the power of 2 AB times C is not necessarily equal to 2 to the power of A 2 to the power of BC. This would mean that A star B star C is not necessarily the same as A star B star C. With this, star is not associative. For our star operation in this given video, it is commutative, but it's not associative because of some important cases here. Given by our definition, A star B is equal to twice the product of A and B as its exponent. Thank you very much for watching.